For centuries, humans have looked up at the sky, gazed across the oceans, and wondered about the true shape of our planet. Is the Earth flat, as some early civilizations believed, or is it round, as science has concluded? This question has sparked debate, exploration, and even controversy throughout history. Today, let's embark on a journey through time, evidence, and reason to discover the real answer. In the earliest days of human civilization, the perception of the Earth's shape was largely shaped by what people could see with their own eyes. To someone standing on a vast plain or gazing out at the ocean, the land and water appeared flat and endless. Ancient cultures, from the Babylonians to the Norse, often imagined the Earth as a flat disk or a vast plain, sometimes supported by animals or gods. These ideas made sense at a time when travel was limited and horizons seemed to stretch forever. However, even in ancient times, some thinkers began to question this flat Earth view. The ancient Greeks were among the first to provide clues suggesting a round Earth. As early as the 6th century BC, philosophers like Pythagoras noticed that the moon was round, and they hypothesized that the Earth might be similar. Later, Aristotle observed that during a lunar eclipse, the shadow cast by the Earth onto the moon was always curved. Only a sphere could create such a consistent, rounded shadow, no matter where the eclipse was observed from on Earth. Around the same time, travelers and sailors began to notice other hints. Ships sailing away from port didn't simply shrink into the distance. Instead, their hulls disappeared first, followed by their masts. This observation suggested that the surface of the water was curved, not flat. In the 3rd century BC, Eratosthenes, a Greek mathematician, made a remarkable discovery. By comparing the angle of the sun's rays in 2 Egyptian cities, Syene and Alexandria, he was able to estimate the Earth's circumference with impressive accuracy. Such calculations would be impossible if the Earth were flat. Over the centuries, the evidence continued to mount. During the age of exploration, navigators like Ferdinand Magellan set sail around the globe. Magellan's crew was the first to circumnavigate the Earth, leaving from Spain and eventually returning from the opposite direction. Their journey would not have been possible if the Earth were flat, as they would have eventually reached the edge or encountered insurmountable obstacles. The view from above provided even more proof. In the 20th century, with the dawn of aviation and, later, space exploration, the shape of the Earth became undeniable. Astronauts aboard spacecraft looked out their windows and saw the unmistakable curve of the horizon. Iconic photographs like the famous Blue Marble, taken by the Apollo 17 crew in 1972, show the Earth as a beautiful, vibrant sphere floating in the darkness of space. But why, then, does the idea of a flat Earth still persist in some circles today? Part of the answer lies in the way our brains interpret the world around us. On a small scale, like a city street or a calm lake, the ground beneath our feet does seem flat. Our senses, designed for everyday survival, are not equipped to perceive the gentle curve of a planet more than 12,000 kilometers in diameter. Without scientific tools or knowledge, it's easy to trust our own perceptions. In recent years, the flat Earth theory has seen a resurgence, fueled in part by the internet and social media. Some people question mainstream science, pointing to conspiracy theories or misinterpreted data. However, the overwhelming consensus among scientists, engineers, and experts from all over the world is clear. The Earth is not flat. Multiple lines of evidence confirm the Earth's roundness. First, there's the force of gravity. Gravity pulls everything toward the center of mass, which naturally forms a sphere. This is why planets, moons, and even large asteroids are round or nearly round, given enough mass for gravity to overcome the object's structural strength. Second, time zones and the way the sun rises and sets. The Earth spins on its axis, and as it does, different parts of the world move in and out of sunlight. This causes daylight to spread gradually across the globe, creating time zones. If the Earth were flat, sunrise and sunset would occur simultaneously everywhere, which is not the case. Third, the phenomenon of seeing farther from higher up. On a round Earth, the higher you go, the farther you can see because the Earth's surface curves away from you. This explains why, from the top of a mountain or a tall building, the horizon is much farther away than at ground level. Fourth, satellite technology and global communication. Modern satellites orbit the Earth, and their paths are calculated based on its spherical shape. GPS weather forecasting and worldwide television broadcasts all depend on the understanding that the Earth is round. These systems would not function correctly if the Earth were flat. Finally, the experiences of astronauts and cosmonauts who have traveled to space. They have observed and photographed the round Earth from above, and their testimonies are backed by countless images and videos shared with the public. The shape of the Earth is more precisely described as an oblate spheroid, meaning it is mostly spherical but slightly flattened at the poles and bulging at the equator due to its rotation. This subtle detail was confirmed with advanced measurements and satellite data. But to the naked eye, and for all practical purposes, the Earth is round. Believing in the roundness of the Earth is not about blindly following authority. It's about weighing the evidence from centuries of observation, experimentation, and discovery. Science is built on skepticism and testing ideas against the facts. The evidence for a round Earth is overwhelming, consistent, and confirmed by independent sources from all over the world. So, is the Earth really flat or round? The answer is clear. The Earth is round, a breathtaking sphere that supports life, inspires exploration, and connects us all. Understanding this truth is not just a matter of scientific curiosity. It's a testament to human ingenuity, our willingness to question, to learn, and to reach for the stars.